Humans are soft. We are slow, we have no natural armor, and we completely lack claws or sharp teeth. Yet we dominate the planet. To understand how we pulled that off, we have to rewind 4.6 billion years. Early Earth was a toxic, erupting sphere of lava. It took eons of planetary cooling and a massive shift in the atmosphere to finally fill the air with oxygen. By the time the Jurassic period arrived, nature had established a clear rulebook for survival. Raw physical scale and brute force dictated who lived and who died. You can see that strategy maximized in the dinosaurs. Species like the Titanosaurus and Brachiosaurus grew into walking fortresses. Their necks extended so high they could casually graze off 10-story canopies. For millions of years, the math of existence was incredibly simple. The creatures with the most mass and the most muscle ruled the landscape. That entire biological strategy failed 65 million years ago. A 15-kilometer-wide asteroid slammed into the atmosphere, traveling at 70,000 kilometers per hour. This satellite view shows the boundary of the impact zone off the coast of modern-day Mexico. The strike instantly vaporized the immediate area and triggered massive, unstoppable tsunamis across the globe. Ash and smoke choked the sky. Months of total darkness brought plunging temperatures and killed off the plant life. The massive bodies of the giant reptiles, which had kept them safe for eras, became fatal liabilities when the food ran out. The asteroid wiped the board clean. Physical strength was instantly neutralized, leaving a massive power vacuum at the very top of the food chain. Small rat-like mammals that had been hiding in the shadows crept out into the ashes. Over millions of years, as the Earth turned green again, they multiplied and diversified. Fast forward to 25 million years ago. The global climate shifted, drying out the African continent. Thick, dense forests began to shrink, replaced by vast open savannas. The primates living in those trees were forced down into the tall grass. To spot predators over the vegetation, they had to adopt a new posture, bipedalism, or standing upright on two legs. By about 300,000 years ago, East Africa saw the emergence of a new species, Homo sapiens. We weren't alone. The landscape was shared with several other human-like species. These early hominid skulls show exactly how we differed. Nature no longer optimized for thick armor or crushing bite force. Our development prioritized cranial capacity. This internal structural change gave early humans the capacity for deep imagination and complex planning. It allowed us to invent ways to hunt and outsmart much faster prey. Then came a leap in processing power, often called the cognitive revolution. Humans developed complex language. We didn't just grunt at a threat. We could specify that a lion was hiding behind a specific rock and formulate a plan to flank it. This language facilitated the creation of shared stories. Other animals naturally form groups of about 50 before social bonds break down. By agreeing on common beliefs, humans bypassed that limit, linking thousands of strangers together into a single cooperative unit. That adaptability was put to the ultimate test 20,000 years ago. Global temperatures plummeted, and massive glaciers advanced across entire continents. Humans didn't have time to wait for evolution to give them thick fur. Instead, they used their minds. They learned to control fire, sought refuge in caves, and stitched animal skins together to block out the freezing winds. This genetic data chart highlights the 1 to 4% Neanderthal DNA sequence overlap present in modern human profiles. It proves that as Homo sapiens expanded, we didn't just fight other hominids for resources, we interbred and absorbed them into our own ranks. Mental adaptation moved faster than the pace of biological evolution. For the first time in Earth's history, a species could adapt to an entirely new, hostile environment in a single generation. Roughly 11,000 years ago, the ice finally retreated. The global climate stabilized, rivers swelled with fresh meltwater, and the soil became rich and fertile. With the environment working in their favor, humans noticed that seeds dropped in the dirt grew into predictable food sources. We stopped chasing herds across continents and built permanent homes near our crops. Agriculture produced a massive surplus of calories. Because a few farmers could feed an entire village, others suddenly had free time. People could dedicate their entire lives to artistry, pottery, and engineering. Someone eventually realized that heating specific rocks caused a liquid to bleed out. That liquid was copper. Casting metal into durable weapons and tools ended the Stone Age. Metallurgy enabled humans to move from surviving the natural landscape to aggressively reshaping it. We were extracting raw materials and forging them into an entirely artificial world. This intense cooperation culminated in the Great River Valley civilizations. Thousands of people organized themselves along the banks of rivers in Mesopotamia and the Indus Valley. In Mesopotamia, society centralized around massive ziggurats. These immense stepped structures projected the power of their rulers and served as monuments to their gods. Look at this clay cuneiform tablet. To manage the massive scale of grain trade and enforce the rules of these sprawling cities, administrators invented writing. Meanwhile, the Indus Valley civilization mastered urban engineering. Their cities were laid out on strict mathematical grids, featuring private wells and intricate underground plumbing. Interestingly, we haven't found massive caches of weapons or royal monuments in their ruins. Artifacts like this square Indus seal suggest a highly organized society that poured its energy into trade rather than warfare. Dominance over 4.6 billion years eventually favored a physically fragile ape that mastered a single collective skill, the ability to cooperate, share a belief, and build a world together.